Okay, so today I would like to do a quick tutorial on decals. So basically what I have here is if I go and hit play, I have a first person character. I don't know if you can see, but it's a first person character um, with his hand holding a ultraviolet flashlight. So if I move around, as you can see, like the walls become lit up with ultraviolet light. So what I want to do with this is actually from an indie game that I made. It was a crime investigation game. What I want to do is, if there's any fingerprints on any of the surfaces of this house, then I want um, the ultraviolet light to show the fingerprints. So basically, what I need to do is I need to create decals. So I'm going to show you how to do that in a moment. First, I'll go into the player blueprint and show you how I've set it up. So basically, it's this is the mesh, and usually when you do a third person, you create a spring arm and then add the camera to the spring arm. But this one has no spring arm; it just has the camera, and it's parented under an empty scene object. In that scene object, the parent socket is the chest bone. So basically, um, instead of following a spring arm, it's just following that particular bone. Another thing that I also added was extra rotation. Uh, so if you don't know how to do this, I have another video. You can go through my videos and see how I do extra rotation for like gaming or whatever. So if I just say hit play, um, if I go down, then the character bends over at the spine, and the light as well as like the hand follow. So if I bend down, I can like see the feet of the character. Um, Basically, how that works is I'll just show you anyways. It's not really like the main point of this video, but so back in the blueprint, the controller rotation, which is the mouse rotation, if um, if there's an input in the pitch, which is the up and down, then I set these two variables. The Y, for some reason, it only works if the Y plugs into the X, and extra rotation alpha has to be set to 1. So these are two variables that I created. One's a rotator, extra rotation, and one's a float. And I reference those within the anim blueprint. And within the anim blueprint, I have the exact same variables, but I set those values with the values from the detective BP, um, which is basically this first one that I showed you. And then these two values gets plugged into this node. As you can see, I plugged them in here. These two nodes get plugged in to a node called transform modify mode. But anyways, that's not the point of this video. The point of this video is to work on decals. So the first thing that I need to do actually is I need to go into my photo editing program, and I'm going to open up an image that I found. Oops, just on Google Images. So I have this image of a fingerprint, and what I'm going to do is I'm going to right click, make sure it has an alpha channel, so add alpha channel. I'm going to select select by color. I'm going to select all the white and delete it. I'm going to create, actually that's good for now. Actually, I'm going to undo that. I'm going to select that tool again and make the threshold a little bit higher so I can get more of it. Okay. So with that done, I'm going to change the color. Usually in forensics, I guess, if you watch, I don't know, like the movies, the light is ultraviolet light, and you put I don't know, some sort of like powder on surfaces to pick up the fingerprints, and then when the ultraviolet light falls on top of the fingerprints with the powder on it, then the color of the fingerprints is like a neon, almost like a glowy sort of green color. So that's what I'm gonna try and give it right now. So also go to color balance and try and give it that. I don't know if it's like completely green. It's like a teal color almost. I think that's good enough. So make sure it has an alpha and the color is like a greenish color. And I'm going to export it as fingerprint color, and I'm going to name it, or I'm going to make it a PNG, because PNG has alphas on it. Okay, so back in Unreal, I'm going to go to my Decals folder, fingerprint. I'm going to import the image that I just created. There we go. And I'm going to right click. I'm going to create a material. This is going to be the fingerprint decal matte. First, I'm going to open this up. So first, with this selected, blend mode has to be, oh sorry, the material domain. By default it's surface, but I'm going to change this to deferred decal. And the blend mode is translucent. I'm going to create a right click and create a texture sample. So there's lots of tutorials on YouTube that does this exact same thing. The thing about this tutorial is that after I do this, it's the stuff that I do after this that's really unique to this particular tutorial. So I need to find the fingerprint that I just created, and the color goes into base color. You can also go into emissive color, and also the alpha goes into opacity, and that's what it looks like. It doesn't look super great, but it's good for now. I'm going to give it a multiplier, a multiply node, and I'll times it by, I don't know, something like 3. And I'll plug that into the emissive and see what that looks like, see if it makes it brighter. It makes it a little bit brighter. But, I'm just going to save that. Okay, so I'm going to go ahead and close some of these windows because I don't, or these tabs because I don't need them. Quickly, I'm going to, I'll just mention that the material that I just created, I could just drag and drop the material, and as you can see, it sticks to whatever surface, as long as it's rotated in the correct direction. If it's just a like rotated like this, then as you can see, like the texture gets distorted. Can't really see the texture. So it has to be the correct rotation and it has to be on a surface. I could do that, but that's not what I'm going to do. Another thing that I have to mention is the ultraviolet light. Basically, kind of like the camera is parented to the chest socket, the spotlight is also parented to the chest socket, but I moved it out in front of the player's hand here. If I put it behind, then it's going to illuminate the arm. I don't want that. I want it to be completely in front of the body. And I gave it that ultraviolet color. I'm not sure if it's like the correct color value, but I don't know, it just looks good, I guess. And you can adjust all these values like the cone angle, inner cone angle, attenuation radius. You can make it like closer or whatever. So yeah, I just wanted to mention that. So like I just showed, you could just drag and drop this material, but that's not what I want to do. What I want to do is I want to create a blueprint class actor, and it's going to be called Fingerprints VP. So if I open that up, I'm going to go add decal, and I'll just name it Fingerprints decal. As you can see, it's created a decal. It's got a default dimension to it, and I'm going to set the material, which is the material that I just created, which is fingerprint decal at. And don't know why, but it's not visible. I'm going to compile. And I'm going to drag that blueprint that I just created into the scene. And as you can see, by default, because in the blueprint it's upright, that's why it's not showing on this horizontal ground. So if I rotate it 90 degrees, then you can see the fingerprint. But obviously the fingerprint's way too big, so what I'm going to do is I'm going to scale this down to, let's just say, 0.1. Let's see what that looks like. Still too big, because this is the player capsule, and that fingerprint is like the size of the player's head maybe. So it's better to scale it down more. Make it like 0.01. And zoom in. Can't really see it. It's really small. You can start to see it now. Anyways, that's not where I want it anyway, so I'm going to delete it. And I'm going to start placing it in places that I want it. So, I'm going to go into the room, and I want to put one right here. So if it's kind of hard to see with like all this stuff, but if I just hit play, I go in, I'll just do one fingerprint for now. There's no sense in doing a whole bunch at the moment. If I go in, you can see the fingerprint. So even if I turn away, you can see the fingerprint there. But that's not what we want. What we want is for the fingerprint to only be visible when the light is hitting it. So the first issue that I need to address is if I try to code this from the character, that's not a good idea because let's just say in this level there's 20 different fingerprints, and that player has to track each and every of the 20 fingerprints. If just say a different level has like 50 fingerprints, then the player, this player BP, has to track 50 fingerprints. So instead of doing it that way, I'm going to make it so that I'm going to code it inside of the fingerprint decal, so that each decal is responsible for tracking the player's position as well as rotation. So first what I'm going to do is with this fingerprint decal selected, I'm going to scroll down the details panel and I'm going to set visible to false. So by default you can't see it. So I'm going to go into event graph. I'm going to create right click and create a custom event. And I want to call this, let's call it fingerprint tick. And in the event tick, I'll create a sequence, and I'll get the fingerprint tick, so that it's constantly firing with the event tick. So this is firing constantly. So from here, what I want to do is I want to set visibility so right now by default I set it to false, but if a certain condition is true, then I want the visibility to be true, so I'm going to click that. But if a certain condition is false, then I want it to be unchecked. So what I need to do is, because this decal is calculating information in relation to the detective, or like the player BP, I need to drag out here and get all actors in class, and I want to get the detective BP, and then I'm going to cast to detective BP, and then from out of this blue thing, I want to get a copy. and I'm going to plug that in. So the whole point of these three nodes is I can extract information from this blueprint. So the first thing that I would like to do is I want to get distance 2. So from the self, which is the decal itself, to the other actor, if the distance is, let's just say smaller, less than, let's just say 300. I'm not sure if that's a good value. For now, I want to use that as the only condition. I want to compile, and then I want to hit play. So if I go back into that room, and I'm staring right at the decal, and I go into the room, I can't see it, but if I get closer, 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 I'm not going closer. Oh, there we go. All of a sudden it pops into view. If I move back, it disappears. So it turns out the 300 was a little bit too high. I'm going to make it 150. So I'm staring right at the wall with a fingerprint on it. If I get closer, can't see, can't see. Okay, so 150 was too low, so I'm going to try 200. There we go. So I'm going to make it 200 actually. 150 is, no actually, oh sorry, I'm going to make it 250. So if I go closer, there we go. So if I move backwards, it's not visible. So the only problem now is if I look away, then the fingerprint is still visible. So it should only be visible if it's within a certain angle of the player's direction. And that direction is basically straight through the camera. So the center of the camera is just straight through the screen. Okay, so in order to make that happen, first I'm going to quickly save. And then right now the only condition is the distance of the character to the fingerprint. So I'm going to disconnect this. So the first thing that I want to get is look at the camera. Get reference to the camera. Find it. Get camera. So I'm getting a reference to this camera here. And I want to get world rotation. So wherever the character is looking, as the character is like rotating around, this rotation changes. So I'm comparing this rotation to the look at rotation of the decal. So find look at rotation. It's actually the camera. I have to get the world location because it's actually looking for a vector for the start. So the camera's location, and I'm going to get actor location. So this is the camera's world location and the location of this actor, which is the decal, which is this. This is what the rotation value would have to be in order for the camera to be looking straight at the decal. So this is what the direction the camera actually is looking at, and this is what the camera angle would have to be in order for it to be looking at the decal. So what I'm going to do is I'm going to take these, I'm going to right click on this and go split struct bin. Split struct bin. So I'm only dealing with the pitch and the yaw. So if I grab the camera, I'm looking at the yaw, or the pitch, which is the Y, the green, and then the Z, which is the left and right look. The roll I'm not worrying about. So all I have to do is compare. If the pitch rotation is smaller, let me think for a second. Oh, sorry. First I need to do pitch minus, subtract the pitch of the look at rotation, then Z minus the Z of the look at rotation. So I'm getting the pitch of the camera and then the pitch of the look at rotation. And I'm constantly, because it's a tick, is constantly being updated. This final value here, or these two final values. One's the Y difference and the other one's the Z difference. So if the Y difference has to is smaller or equal to, I don't know, let's just say 10 degrees. And this one is also less than or equal to, let's put 10 for now. Basically what I'm trying to figure out is the max value of this light. So the center would be the camera, and then the angle from the camera to the farthest edge of this inner cone. I'm not sure if it's the inner cone or the outer cone, but for now I'm just going to guess. So all these three have to be true, so I'm going to get and another and. So all of this has to be true in order for the decal to be visible. If one thing is off, then it's automatically going to set it to invisible. So if I go back in, so if I get close enough, you can see the decal, but okay, that was kind of weird. Oh, there we go. So I can see it now, but if I move away, I can't see it. Okay. If I rotate this way, that's weird. I'm going to make it so that the outer cone is a little bit smaller, the inner cone is a little bit smaller. Compile that, and we'll see what that looks like. So if I walk up to that wall, okay, so I can see it, but as soon as I rotate away, it shouldn't be visible, but it is. Maybe 10 is too high. It's invisible now. There. Let's see what, if I set this to, let's see, 6 degrees. Oh, the one thing that I forgot. You know what? I'm going to change this to, change it back to 10. I need to get the absolute value of these numbers. So it's disregarding the plus or minus sign. So this could be like, just say looking left or looking right. So if it's looking left, then it's a negative. If it's looking right, then it's a positive value. But this absolute node disregards that. It just looks at the numerical value without regards to whether it's a negative or positive number, which is what I want. So maybe that's why it wasn't working before. But now I'm going to try again with just the 10 degrees. So if I play. Where is it? Oh, there we go. That works very well. So I can see see the fingerprint. But as soon as I move away, rotate away, it disappears. If I rotate towards it, I can see it. And then if I rotate it more, then it disappears, which is awesome. The only problem is the fingerprint, it pops in and out of existence. So why am I not seeing it now? Okay, it's popping in and out of existence, but I don't want that. I want it to be more, I guess, gradual. I want it to like fade in and out. First, I'm going to turn down the intensity to, let's just say, 500. And let's see what that looks like. Okay, I think that's a little bit better. It's a little bit less bright, so it's easier to see the fingerprint. I'm going to change this value back to 300 because I want the player to be able to see the fingerprint sooner. So let's change it back to 300 instead of 250. Okay, so I'm going to quickly save all. So in order to make it fingerprint fade, instead of like popping, like instead of having the visibility just like pop, I'm going to make some changes to this. This is only necessary so I can get these initial values, the 10 degrees for the rotation and 300 for the distance to the decal. So first I am going to do I'm going to make it so that it's only going to disregard the distance for now. So I'm only dealing with the rotation. And what I'm going to do instead is I'm going to do I'm going to times this absolute value by a factor. So I'm going to create a variable. It's going to be called, we'll call it distance factor. And it's going to be a float. And I'm going to take this absolute value and I'm going to multiply it. I'm going to get a multiply node, and I'm going to multiply it by this distance factor. So this final value would be the absolute value of the angle times the distance factor. So if I compile this and select this variable that I just created, I'm going to set the default value to 1 just for now. So what I want to do is I want to set this distance factor with this distance node, or this get distance to. So from here I'm going to say branch if distance to player is greater than 300 or smaller than 300, first I'm going to start with whoops, is greater or equal to 300, then this is going to be 0. Distance factor is going to be 0. If it's greater than 300, that means he's too far away. That means this is 0. That means all these values are going to be multiplied by 0, which makes this final value 0. Actually, this is incorrect. Distance factor should be greater than 10. I'm going to just set these values for now. So I'm going to go, if this is false, if it's not greater than 300, then it's going to be another branch. I want to get rid of this multiply. I want to use this distance factor somewhere else. I'm going to if distance is less than 300, but greater or equal to 200, let's say 250, then first I'll make a whole bunch of these. So the first one is greater, checking to see if the distance to decal is greater than 300. And it's checking to see if it's between 300 and 250. And it's 250 and 200. This one is checking to see if it's between and 150, and this one's going to be smaller than 150, greater or equal to 100. And I'll do one last one where I'm checking to see if it's smaller than 100. So this very first one, the value is 0. This very last one should be, the value should be 1. So all these in between should be in between values. So I've got 0 and 1. So I can make 2, 4, 6, 8. So I can do multiples of, or increments of 0.2. So this will be 0.2, 0.4, 0.6, 0.8. Oh, another thing that I forgot is with this material, I'm going to create right click on the material, create material instance. I'll open this up. So back in this fingerprint material, where is it? The opacity. Okay, so the first thing that I have to do is I have to go into the material, and out of the alpha, I'm going to multiply, and I want to plug it into opacity. So if it's 1, if you notice, if it's 1, then I can see it. If I set it to 0, then it's invisible. If I set it to 0.5, it's, let's see, it's half visible. But if I set it back to 1, when it's set to 1, it's completely visible. So because I have this now, if I go into my material instance, it if I do this drop down, it's visible here. So if I check the visibility, which is the name of this scalar parameter, and just say I adjust this value, by default it's 1. If I go all the way down to 0 or below 0, it disappears. If I go back to 1, then it's 100% visible. So I'll set that to 1. And now I can adjust this within script. So back here I have the visibility and invisibility set, but instead of using that, I'm going to set the decal to visible by default before I had it invisible, and I'm going to disconnect these, and what I'm going to do is I'm going to create dynamic material instance. Sorry. Create dynamic material instance, and I want to grab the one that says fingerprint decal, which is referring to this here. And from here, I'm going to pull out of this return value, and I'm going to get set vector parameter value. And what that parameter value is basically this visibility, or in the material instance, visibility. So here, I'm just going to type in parameter name, visibility. And the value is going to be the distance factor. So if I compile that, and then I go play, oops, go to the room, so if I move away, I should get brighter the closer I get, but as soon as I move away, it fades out. But it doesn't do anything when I rotate away, so I need to fix that. One thing I forgot to mention is the decal selected under the decal material. Originally it was fingerprint decal material, but since I created the decal material instance, I have to set the decal material to that. Otherwise, it's not. This isn't going to work. Another thing that I want to do is the event graph. I am going to break this up so that I'm going to get rid of this and node. And in the sequence, I'm going to bring this over here, copy and paste. The one thing I think I forgot to do is so this top one is the pitch, which is looking up and down, and this bottom one is Z, so looking left and right. So let's just say for pitch, I need to grab the difference between so I'm getting the difference between the the angle that the camera is facing versus the angle that the camera needs to face in order for it to be looking at the decal. So I want to grab that value, and I'm going to times it by I'm going to try multiplying it by the distance factor, and then plugging this in to the value. And I'll do the same for the bottom, where I get this value, then I multiply by this. Let's see what that looks like. So when I'm within a certain distance, the decal is visible, but as soon as I rotate away, it makes no difference. Okay, I set it back to the way it originally was. So the two differences, the y difference and the z difference, if both are less than 10 degrees, then set the value, or set the value of the material instance. But I'm going to disconnect this, and instead of going through the branch, I'm going to set it directly like that. So this one is constantly being updated no matter what. But now what I'm going to do is I'm going to create two more floats. One's going to be Y rotation factor, and another one called Z rotation factor. So right now the visibility is only set by the distance, so I'm going to get the Y rotation and Z rotation. So I'm going to get the distance factor minus the Y rotation, and this value minus the Z rotation factor. So compile. By default, both of these are set to 1. So what I'm going to do differently is, because I've already set the distance factor, because I've already set the distance factors, all I need to worry about now is the rotation factors. So going to move all this down because all this stuff comes first. So what I'm going to do, I might as well just create a new sequence. First I'll say I'm going to remove that, and I'll get greater than 10, greater than 10. So if the Y rotation is greater than 10, the Y factor is going to be set to 0, and if it's greater than 10, then the Z factor is going to be set to 0. So I'm going to, what's the best way to do this? If this is false, if it's if ABS is absolute value is greater or equal to, or sorry, smaller or equal to 10, greater than greater than, I'll go increments of 0.2, so or sorry, increments of 2. It's greater than 8 and smaller or equal to 10. So before I set these values, I'm going to those be smaller or equal to 8, greater than 6. This will be 6 to 4. And this very last one will be smaller than 4 degrees. That means this last one is going to be 1, so I've got 0 to 1, so increments of 0.2. Two, 4, 6, actually I could use another one. Should be 0.2, 0.4, 0.6, 0.8, and one last one. Value will be 1. Plug this in. Okay. So for this last one, so these values have to be 0, 0.2, 0.4, 0.6, 0.8, and then 1. So basically, this is the final calculation here. So what this actually should be is, if the Z rotation and the Y rotation just say are both 0, that means the player is looking directly at the decal. That means 0 is deducted from the distance factor, but it's only deducted if it's greater than 0. So I don't want to deduct both of these actually. What I want to do is I want to add both of these together, then divide by 2 to get the average value, and then I want to subtract that from the distance factor. So let's just say both of them are greater than wait a minute. This is all backwards. I need to make this one, and this is 0.8, this is 0.6, 0.4, 0.2, 0. Same with this one. The z factor is 0.8. It's 1, and then 0.8, 0.6, 0.4, 0.2, and then 0. So let's just say the rotation, just say of the y, for example, is greater than 10. And let's just say by chance the z rotation is greater than 10 as well. That means the rotation factor is both 1, so 1 plus 1. So 1 plus 1 is 2, but you can't take away 2 from the distance factor because the max value of distance factor is 1. So you have to take the average of the two, and you have to add them together and divide 2 to get the average, and deduct that from the distance factor. So let's see if this works now. So if I go into the room, you can see it is not disappearing. What am I missing here? Okay, so I've finally got it to work now. So basically, one thing that I did wrong was this parameter I got, the original one that I got was set vector parameter value, but that was the wrong one because I want in my material, it's this is a scalar parameter, not a vector. So I had to get, if you read here, it says set scalar, not set vector. So I'm going to delete that. And make sure you type in the parameter name. Again, make sure the rotation, y rotation, if the difference is greater than 10, then rotation factor is 1. That means I can deduct 1 from the distance factor. If it's smaller than 10 and greater than 8, then I can deduct 0.8, 0.6, 0.4, 0.2. But if the angle, the y angle is smaller than 2, then I deduct 0. Same with the z rotation. So if it's the rotation is greater than 10, then it's 1. If it gets closer to smaller or equal to 2, then the Z rotation is 0. So basically what I'm doing is I'm taking those values, the Y rotation, X rotation, and I'm adding them together and dividing by 2. So I'm averaging those two values, and I'm deducting that from the distance factor. So, so I'll show you now. So I'm plugging that in into this value. So if I go ahead and play, and I go back, so if I go get within a certain distance, you can see the fingerprint. But as soon as I rotate away, the fingerprint fades away. I get a little bit closer. It's a little bit too close. Same deal here. If I rotate away, maybe it's too close. As I move back, it gets really, really faint. You can barely see it. Okay, that's all I wanted to do for this video. I think that was pretty good. Yeah, I just wanted to make this one video. If there's anything unclear, please leave a comment at the bottom. If not, I hopefully you enjoyed it, and please stay tuned for more videos.